Lauren, and today I will be presenting high resolution of whole mount mouse organs with axially swept light sheet microscopy. So to start, we provided a potential important insight, the field of tissue engineering and better 3D modeling of whole organ structures in mammals. And this is achieved through three aims. Aim 1 is to build and operate an axially sweeping light sheet microscope to overcome field of view limitations. Aim 2 is to identify fluorescence-inducing dyes and antibodies. This will aid in the visualization of vasculature of whole organs. And Aim 3 is to design an optimal tissue clearing protocol. It will A, improve penetration, B, minimize shrinkage and also tissue damage, and D, homogenize optical properties to prevent light scattering. So a bit of background. Figure 1 illustrates a field of view with a small field of view in focus. So the point of ASSLSM is to have a Gaussian beam of light that samples the sample from the side using an orthogonal field view, and it will be sweeping alongside the sample, while at the same time a camera has active pixels on in focus. This provides a large field of view with a minimal out of focus view. Additionally, current tissue clearing methods have interfered with the light dispersion and antibody staining. So binary as a clearing method has been investigated to introduce a potential method that will provide clearer and higher quality images alongside this imaging technique. So if we move to experimental setup, figure 3 illustrates a sample in the subvoxel light sheet microscopy setup. Do know that the sample is tilted to provide overlap of images when imaging, and that helps rendering later on in the protocol. Flow of binary clearing system, we can see that the first main step is fixation, and then we clear and RI match in the mounting solution to an RI of 1.46, and then we stain using the immunohistochemical methods of secondary and primary antibodies. Some core technologies include the binary rapid clearing, which does not need the traditional BABB requirement of butanol, and this aids in the decrease of fluorescence emissions and signal-to-noise ratio. And this also validates the ASSLSM system, so sort of cyclical in that way. So binary has not been used very often in this system. So this could reduce signal-to-noise ratio, it could reduce quenching of antibodies and potential light scattering, and it also reduces time for the scientists in reduction of wait time. Some trade-offs include when imaging subcellular structures, which need higher magnification, the beams must be thinner, and this reduces temporal resolution and volume of view. And if we move to experimental results, we have figure 4 that illustrates the clearing and mounting solution quality with a bit of autofluorescence, which is the yellowing that you see. And then figure 5 is some deconvoluted rendered images of cardiac organoids that was cleared with binary. And we have a disease and wild type. So to conclude, binary is a viable method to use with ASLSM, and it has seen to decrease some light scattering. Some constraints, though, is that the organs did not come non-cardiacally, transcardially perfused, and the organs are cleared. They have to be cleared at one at a time. Mice brains also must have a separate solution to be ordered, and further optimization is needed in order to better sampling rate, elimination of photobleaching, and to better see myocardiac cells regeneration and differentiation. So special thanks to Dr. Lee, Dr. Tenekar, and Vi of Dr. Wing's lab. Thank you.